Hello, my name is Jason Johnson. Thank you for watching my videos. This video is on the Raptor flowchart-based programming, and we're going to be looking at Chapter 6 for the Prelude to Programming textbook, and we're going to look at the challenges for Chapter 6. The first challenge we're going to look at is Alberta Einstein teaches a business class. To evaluate the students in the class, she is given 3 tests. It's now the end of the semester, and Alberta asks you to create a program that will input each student's test scores and output the average score for each student and the overall class average. And the hint on this one is the outer loop should allow for Mrs. Einstein to input all of the students one by one, and the inner loop should accept the 3 exam scores and compute the average for each student. So what we're going to do on this, we're going to tell the user what we're doing. This program allows a professor to enter 3 test scores. And this one seems complicated, but it's really not if you break it down into small bite-sized chunks. We are setting our variables first. So we're going to come over here and we're going to set our variables, and we're going to give the user a choice of yes. And if they put in something else, then it will, we can have a yes/no choice. We're going to set our student count to 0 because we need to know how many students we have. We need to do a class sum. So we need to sum up how many class scores there are, and then we need to do a student average, and then we need to do a student ID. So then it's going to come back over to the main program. We're going to start an outer loop and an inner loop in here. So we've got a nested loop on this one. So we're going to start our first loop here, and the first loop is going to ask for our student count. It's going to say, set our student count to student count plus 1. So it's going to, so our student count variable is going to be student count plus 1. It's going to set our class average to 0. And then we're going to say, take the class sum plus the student average and add that to the class sum. And then we're going to say, enter a new student record. We're going to type yes for, yes, N for no. We're going to tell the user that. And then we're going to do a choice here. We're going to say, if we do no, then we're going to come down here, and I'll cover this here in a second when we kick out after we talk about the rest of this loop. So if the choice is yes, or if the choice is yes here, enter a new student record, type yes. It's going to come and it's going to, if it's no, it's going to set the score to 0. The count to 1 and the student sum to 0. And then it's going to loop again, and it's going to say count. If the count greater than 3, then enter the test score and the count. Because remember, if we come back up here, we're going to say enter 3 test scores. So that 3 up here is critical for us to be able to say down here that we're going to set our count is our count greater than 3. If it is, then it's going to come out and it's going to say put our student ID to the student ID plus 1. And then we're going to set student average to student sum divided by 3. So we're going to take those 3 scores and add them as an average. And then we're going to say the average for the student, and we're going to output that is the student average. And then it's going to come back all the way back around again. It's going to come back to the count. It's, add to the count plus 1. It's going to do the class average back to 0. It's going to do the sum, and then it's going to say, do we want to enter another one? And if we do, we're going to come down here and we're going to say set the student count is 1 or student sum of 0. If it is, there no student data was entered. This is our fail-safe to be able to say, did we only have 1 student? Then we're just going to, or if the student sum was 0, then it's just going to kick out and there was no student data. If the student count is not 1, if it's greater than that, then we're going to say no. Because remember, our student count we set up here to 1. Student count we set to student count plus 1, right? So down here, it come in, and then now since it's greater than 1, it's going to take whatever the class average was that we set back up in this other loop, and it's going to say set the class average to the class sum divided by the student count. So if we put in 3 students, it's going to take those 3 scores for each one of those 3 students. It's going to take that sum and it's going to divide it by those numbers of students, and then it's going to give that. And what I'm going to do is I'm going to step through this program. We're not just going to run this one. I'm going to step through it to show you what it's doing, at least for the first time. So it's going to output, it's going to tell the user what we're doing. It's going to set our variables. So it's going to come over here and set all of our variables, and I'm going to click through these fast. So we're setting choice to Y, class sum to 0, student average to 0, student count to 0, student ID to 0. And then we're going to come and we're going to start our loop. We're going to set our student count to student count plus 1 because we set our student count to 0 in our variable. Now we could have set our student count to 1 automatically already, but this is just showing you how you can add to the count with an assignment. And then we're going to set our class average to 0, and then we're going to ask the user, do we want to enter a enter a new record? I'm going to type Y for yes, enter a new student record, and it's going to say, is the choice equal to no? Well, it's going to go over here to yes. Is the choice equal to N? I put Y, so this is a flip, right? So is the choice equal to N? If it was equal to N, we didn't end the program, or we didn't finish out. So we're going to say no, we put in a Y, because we wanted to enter another record. So it's a flip on this and saying, okay, since we entered a Y, it's going to come down here and say, no, we didn't enter no, we entered Y. So we're going to set our score, our count, and our student sum. Now we're going to set our store, our student count, and our sum. See, score, student count, and student sum. And then we're going to start another loop here, and we're going to say, is our count greater than 3? Well, our count is 1, so it is not greater than 3. So it's going to come down here, and it's going to say, enter a test score. And we're going to enter our first test score, and let's say that's a 75. And we're going to add 1 to the count. So now our count's going to be 2. And we're going to say the student sum should be the student sum plus the score. And so now the student sum is 75. It's going to loop back around through, and it's going to ask for the count again. And it's not greater than 3, so it's going to ask for another student score. And let's say we put in a 90 this time. And it's going to change our count. Say our count's going to go to 3. And we're going to go around again. And is our count greater than 3? No, it's equal to 3. So we're going to ask for one more score. And let's say that we put in an 85 on this one. So now we have 85. We're going to come down and we're going to add that to it. So now we have 250 divided by, which will be 250 divided by 3. And it's going to count. And now the count said, yes, it's greater than 3 this time, right? Because the count's 4. And it's going to come on down. It's going to say the student ID, set the student ID to student ID plus 1. So we're setting our count, right? We're changing our count for our student IDs. So now we've got 1 student in. So we've added 3 scores for 1 student. And then it's going to output and say the average for that first student is 83.333. So we output that to the user. And then we're going to go back around again, since we're looping inside of a loop, and we're going to say student count plus 1. So we've increased our student count to 2. And then we're going to enter our records. Now I'm going to go ahead and press play to go ahead and execute this full speed. And we want to enter another student record because I want to get at least 2 students in here. So we're going to do yes again. It's going to come down and it stopped to enter a test score, but I'm going to show you my student count. My student ID is back to 1. Student count is 2 though. Our average is still here, but this is going to change here in just a second. And we're going to enter our first student score. So let's say a 95. It's going to loop back around. And let's just say we're going to do 3 95s. We'll do a 95, a 95. So 95 plus 95. And then let's say they got 100 on this one. So it set our student count to 4. It set our new average to 96. And now it's asking us, do we want to enter another student record? But it says our average for student number 1 is this. Our average for student number 2 is this. Well, our student ID count is now 3. Our student count is 3. Our student ID is number 2. But we're going to go ahead and say, no, we do not want another record. And it's going to come down here and it's going to say, is the student count equal to 1? We have data. So we're going to say class average. It's going to take the class, it's going to make the class average of the class sum. So our class sum was 180 divided by the student count. And the class average is that plus the class average. So the class average was 90. So it took 83.333, 96.66667, divided that by 2, and that gave us the 90. So that was challenge number 1 for chapter 6. Challenge number 2 is we need to create a program that will find and display the largest of a list of positive numbers entered by the user. The user should indicate that he or she has finished entering the numbers by entering a 0. So what we're going to do is we're going to tell the user what we're doing here. We're going to set our variable of number to 0 and our largest to 0. We're going to set largest to 0. And then we're going to ask the user to enter any positive or negative number except 0. And enter 0 when you're done. So we're going to tell the user, hey, you can put any number in, positive or negative, but when you're done, put a 0 in. And then we're going to start a loop, and we're going to say, is the number equal to 0? If it's equal to 0, it's going to finish the program and say, the largest number is your list, largest, and it's going to finish it. If not, it's going to say, is the number greater than the largest number? If it is, then it's going to take the largest and set it to whatever that number was. If it's not, it's going to put that as the number, and it's going to say enter any positive or negative number, and it's going to continue to do that. So I'm just going to run this. It's going to come through, largest number, and enter a positive number, so let's put in 100. And then let's do, so the largest is 100, right? And then our number is 100. So let's put in 50 for this one. So now our number is 50 and our largest is 100. And it didn't change it. It didn't change our largest. And then let's put in 50 again. And it's going to loop around and it's going to say, nope, 50. So, and then let's put in 150. So, oh, now my list is larger, 150. And then let's put in 0 to finish the program. So what that was doing is it was outputting our 100, our 50, our 50, and our 150. But then it stored the value and said the largest number in your list is 150. So that was programming challenge number 2 for chapter 6. Programming challenge number 3. For a list of numbers entered by the user and terminated by 0, write a program to find the sum of the positive numbers and the sum of the negative numbers. So we're going to write the program. We're going to tell the user what we're doing here. We're going to set our positive sum to 0, our negative sum to 0, and number to 0. And then we're going to ask the user to put a number in, enter 0 when done. We're going to start a loop here, and it's going to say, is the number equal to 0? If it is, it'll kick out, and we'll get back to that one in a minute. If it's not equal to 0, we're going to say, is the number greater than 0? So we're saying, is it 0 in the program? If it's not, we need to check and see if it's a positive or a negative number. If it's greater than 0, we know by logic that it's a positive number. So we come over here and we say, add to the positive sum plus whatever the number is. If it's below 0, which means it's negative, add to the negative sum, whatever the negative sum is, plus the number. And then enter another number, and then 0 to finish, and then it will just continue to loop around until we put 0 in. And then once we put 0 in, it will come down here and it'll say the sum of the positive numbers is, because it'll be calculating what the positive numbers are, and then the sum of the negative numbers is what it is. So let's run this program. I'm not going to do any toggle breakpoints. I'm just going to run it. So we've set our values for negative sum, number, and positive sum. Let's enter our first number. Let's say 150. It's going to loop around, and that was a positive number. So see, it added a number to 150 and a positive sum to 150. Let's put in 150 one more time. So now we've got a positive of 300 and a negative, or a number of 150 still. And now let's put in a negative 150. And so my number changed to negative 150, but my negative sum also changed to negative 150. But it did not affect my positive sum because we went to the one side of the loop versus the other, or the one side of the decision tree versus the other. Now let's put in another negative 150. It's going to come back around. It's going to add to the negative sum. And let's go ahead and put a 0 in to finish. And then it will output our two values. The sum of the positive numbers is 300. The sum of the negative numbers is negative 300. So this was challenge number 3. Challenge number 4 is a fun one to create. We're going to do a program that simulates the process of dealing cards from a 52 deck card by generating 1,000 random integers in a range of 1 to 52. We want to assume that the numbers 1 through 13 represent clubs, 14 through 26 represent diamonds, 27 through 39 represent hearts, and 40 to 52 represent spades. And then we want to display the number of times each suit occurred in the 1,000 deals. Now what we're working here with is a number of different things, but if we take it in small bite-sized chunks, it's pretty easy to write the program. We have to remember that we're dealing with 1 to 52, and then we're dealing with 4 suits of numbers. You know that we're dealing from 1 to 13, so that's, we're dealing with clubs, diamonds, hearts, and spades. So we have to use the random generator in Raptor to generate a number between 1 and 52, and then do that 1,000 times. So we're going to count up to 1,000 until we get 1,000 deals, and then each time it does a deal, it's going to check to see which value it's in, and then put a number in there and increase that. So what we're going to do is we're telling the user what we're doing. This program simulates 1,000 deals from a deck of cards. It will count and display the number of cards in each suit. We're going to go get our variables, and we're going to set our clubs, our hearts, our diamonds, and our spades to 0. We're going to set our card to 0, and we're going to use K as our counter. K is going to be our counter, and we're going to set it to 0. So then it's going to come back over here, and it's going to start a big old loop here. It's going to start a big old loop here, and it looks intimidating when you first see this big loop on here, but really just, it'll be fine. You'll be able to create this. Just do it one step at a time. So first you're going to make a decision tree, and you're going to say, is my K count greater than or equal to 1,000? Because this is going to set for our 1,000 deals. Now we know that we've set our K count to 0 So the first time through, it's going to do 0, and then it's going to count all the way up to 999, which will give us 1,000. 0 to 999 is 1,000. Once it gets to 1,000, it's going to kick out, and I'm just going to show it what it'll do it at the end. It's going to say how many numbers do we have in clubs, how many numbers do we have in hearts, how many number of diamonds, and how many number of spades. Now, what we're going to do inside here is each one of these is a stacking, or just kind of a what I call a cascade. We're first going to set our card number. We're going to set our floor, and we're going to use the random generator, and we're going to generate a number times 52 plus 1. So we're saying 1 to 52, so times 52 plus 1. So this will be our random number generator, and it's going to continue, it's going to generate the number, and then it's going to say whatever my number, it's going to set card to whatever that random number is, and then it's going to say, is the card less than 14? Because remember, we said 1 to 13 should be a club, right? So 1 to 13 is, less than 1 to 13 is going to say club and add to club 1 and add to the count. If it was 14 to 26, it's going to be a diamond, and it's going to add it into there. So it's going to come down here, and it's going to say, is the card a 14 through a 26? Because is the card less than 27? If it is, then add to the diamonds. If the card number is 27 to 39, because we're checking to see is the card less than 40, then yes, add it to the hearts. And then is the card 40 to 52, because less than 40, and anything above that, it'll be a 52, add to the spades. And then come on down here and say, take my K count and add 1 to it. So we're going to say my K count the first time through is 0, and then it's going to say 1. And then it's going to come all the way back up over here and loop back around. And it's going to then come back through. And is my K count 1,000 yet? No, it's not. So it's going to continue to go through. Now I'm going to run this slow. I'm going to run it through once real slow and then show you, because this takes a little, if you ran it through on the normal speed, it would take a long time to do this. And we don't have time for that in the video. So we're going to set our variables, set our K count, and then we're going to start our loop, and we're going to check to our, and it's just going to go through here. And our first number was, and I'm going to pause this, and our number right now, say our card is 32, so it's checking our card, so it's coming back through the loop, and it checked, and it says with it 32. Well, since it was a 32, it went into the hearts, right? So my hearts went up by 1. The first card, I don't remember what my first card was, but it was a diamond. I didn't see what it was, but it was a diamond. So it was between 14 and 26. And then the next time it comes through, and I'm going to toggle a breakpoint right here. I'm going to toggle a breakpoint so it gets here. And so now my card is 42. All right. Yeah, now my card is 42. And it's going to add to the spades this time because, see, it's greater than 40. So if we finish, it'll come on back around through, and it'll add that to the spades. And then the next card, now my card's a 2, so it's going to add to the clubs. Clubs didn't have anything yet. So now I've got diamonds 1, hearts 1, spades 1, clubs 1. It just happens to be that it's evening it out. But I'm going to remove this toggle breakpoint. I'm going to add it to this. I'm going to change the speed up really high, and we're going to do this really fast. Still not fast enough. Let's go up all the way faster. There we go. Bam. There we go. And now it output to us, and it said clubs was 256, hearts is 235, diamonds is 270, spades is 239. If I run it again, I'll get a different distribution. So we ran it again, and we got a totally different distribution where clubs was different, and you see the numbers kind of even out. Over big numbers, those numbers will even out even more based on averaging. But that is how you take a random number between a certain number, 1 to 52, count it, and then sort it out into where it needs to be, and then do that count. And that was challenge number 4. Challenge number 5, we need to create a program that formats the output of a user's name using the length of function. We're going to use the length of function. And we need to use the print statement and the NL indicator to create this pseudocode. The user should be able to select the symbol used to form the borders of the name. If the user's name is Howard Heisenberg, and they choose a asterisk as the symbol, the output should look something like this right here. So what we're going to do is we're going to start our program. We're going to set our variables, and we're going to set our name to a string, number to 0, symbol to a pound sign, and count to 0. And you'll see where this comes into play here in just a minute. And then we're going to ask the user to put in the name, and we are using, and I'm going to come back over here real quick, and I'm going to copy and paste this in so I don't have to type it in. And then we're going to say the length of the name. So what is the length of? We're using the length of. What's the length of the name? And set that to a set number to the length of the name. And then we're going to say choose a symbol from the keyboard, such as asterisk or ampersand or something else. I think I'll use the pound sign. And then we're going to go into a loop, and it's going to say count the number. Is the count greater than the number? And our count, remember, we set to 0, and our number is our number of our length of name. So it's going to say count that, and it's going to keep counting, and it's going to put symbols on there. It's going to say put the symbol until the count, and then add to the count. So put the symbol, and then we're going to add to the count +1, come back around, add again, add again, add again, keep until we get our count and our symbols. And then we're going to say put the symbol plus the symbol plus the name plus the symbol plus the symbol, and it should look like what we did right here. We're going to use asterisk. It should look like that. So let's see if we can get it. And then it's going to come down and it's going to say loop again, and it's going to say count the number, and it's going to put the symbol, and it's going to get the count. So we've got loops, and then we've got another loop down here. So we're just going to run this, and we're going to enter our name here, Howard Heisenberg, and it's going to set our username. And now we're going to choose our symbol, and I'm going to go ahead and put an asterisk in. So our symbol right now is the pound sign, but it's going to change it to the asterisk. And it's going to count, and it was 18. And then it output, and it's a little bit off right here. It's off just by a little bit, but it still gets close enough. So that shows you how to use the length of name. That was programming challenge number 5. Programming challenge number 6 is interesting. We get to do the card game of war. It consists of 2 players having a deck of cards. For each play, the person turns over the top card in their deck, and the higher card wins that round. And whoever wins that round takes the card and gets to count it towards their pile, or towards their count. The game continues until one person has all the cards, and the other one has none. To create a program that simulates a modified game of war, the computer will play both hands as player 1 and player 2, and for each round will generate 2 random numbers and compare them. If the first number is higher, player 1's score is increased by 1, and if the second number is higher, player 2's score is increased by 1. If there's a tie, no score is incremented, so no change. And when when one of the players reaches a score of 10, we're going to simulate 10 wins, 10 cards. We're not going to do 52. We're going to do 10. That player should be deemed the winner, and the game ends. The range of numbers should be 1 to 13 to simulate the values of the cards in a deck. So we have ace, king, queen, jack, and then 2 through 10. So what we're going to do is output to the user what this is doing, which is what I just explained to you on the output. We're going to set our variables. We're going to set our player 1 to 0, player 2 to 0, 1 card to 0, and 2 cards. So we're going to have 1 card, 2 card, and player 1, player 2. And then we're going to come down here for our loop, and we're going to say, is player 1 greater than or equal to 10? Or is player 2 greater than or equal to 10? In other words, does either player, 1 or 2, have a score of 10? Is it greater than or equal to 10? So once one of the players gets to 10, the program will end and come down here and say, is player 1 greater than player 2? Yes, then say player 1 wins. If player 1 is not greater than player 2, then player 2 wins, and then it gives that value. But let's look at the heart of this here. So we're going to set one card to a random number between 1 and 10. Random times 10 plus 1. And card 2 is going to be random times 10 plus 1. So 2 card. So we get our random, selects random card for player 1, for player 2, and then it's going to say, is 1 card greater than 2 card? So if 1 card is greater, then player 1 gets a count. If 2 card is greater, because see, it's a flip, so 1 card is not greater than 2 card, then 2 card is greater than 1 card, then yes. So see, is 1 card greater? And then here, 2 card is greater than yes, then player 2 gets a count. If no, because this is our 0, right? So if 1 card is greater than 2 card, if it's not, and then now if 2 card is not greater than 1 card, so we've compared one way, now we're comparing the second way. So if we get a card of, let's say if we get a card of 5 and a card of 5 here would say, is 1 card greater than 2 card? So 5 and 5, no. And then 5 and 5, no. And then so we don't get any count, we come back around on our loop. But if one of them is greater than the other, then we'll give a count for player 1 or a count for player 2. So I'm going to step through this. I'm going to set a toggle point right here. So we'll go through this once and see what happens. So we're going to do all of our output, and we've stopped at our breakpoint here. So is player 1 greater than or equal to player 2? And we're going to continue on. And our card was 10. So our 1 card is 10 and our 2 card is 10. And since they were both the same, neither one got a count. Hey, that was awesome for the first time. So let's go through it again. So now 1 card is 8 and 4 card is 2. So player 1 got a count. And go through it again. 5 and 2. So they're going to keep counting up and keep counting up. And I'm just going to keep pressing player. I'm going to remove my toggle point and then let it go through. And so player 1 only won 8 rounds. Player 2 got 10. And that means that player 2 wins. If we ran it again, and I'm going to slow it down just a hair here. There we go. And it'll go through again. Set our variables. And it's going to count again. See, it's doing our cards. Each one, I'm going to make it really fast. There we go. So player 1 got 7, player 2 got 10, and then you can continue to do that. The interesting part about this program is you could take this and then take this data here and dump this data out into a program to do some statistical analysis on it and say, okay, over 1,000 games, how many times did player 1 win? How many times did player 2 win? So there's all kinds of practical applications for this type of programming. So this has been Programming Challenge number 6 for Chapter 6. Thank you for watching my videos. I appreciate you subscribing. I appreciate you sharing my videos with others. I do appreciate the comments that you leave on my videos. I do read them all, and I hope you have a great day. I hope you're safe, and be excellent to each other.